प्यारे बच्चों, आज हम 12th क्लास फिजिक्स की फर्स्ट यूनिट के एक टॉपिक इलेक्ट्रिक पोटेंशियल एट ए पॉइंट ऑन एक्सियल लाइन ड्यू टू एन इलेक्ट्रिक डाइपोल करने वाले हैं। इसके लिए सबसे पहले लेट ए बी पॉइंट ए and point B, AB be an electric dipole having charge minus Q 8 point A and plus Q 8 point B. Both the charges are separated by the distance 2A. Distance between point A and B. O is the center of dipole AB. Let a point P be any point on the axial line where the electric potential is to be determined. Axial line के ऊपर हम कहीं एक पॉइंट P लेते हैं जहां पर इलेक्ट्रिक पोटेंशियल मेजर करना है। डिस्टेंस बिटवीन point O to P. Let distance between point O to P is R. Therefore, we can write OP is equal to R, AP is equal to R plus A, R plus A, and OA equal to OB is equal to A, and BP is equal to R minus A. Now, potential 8 point P. Now, potential 8 point P due to positive Q charge is 8 point B. Therefore, the potential 8 point P due to the positive charge is equal to, we can write V1 potential. We know that potential electric potential V is equal to 1 upon 4 pi epsilon naught Q upon R. Therefore, here V1 is equal to 1 upon 4 pi epsilon naught Q. B point के ऊपर प्लस चार्ज है, we can also write plus Q divided by distance between point B to P. B to P we can write R minus A. First equation. And also potential 8 point P due to minus Q charge is V2 is equal to 1 upon 4 pi epsilon naught. Here the charge 8 point A is minus Q. Therefore, we can write minus Q divided by R plus A, the second equation. We know that total potential 8 point P. So, total potential 8 point P is equal to V1 plus V2. Here V1 is equal to 1 upon 4 pi epsilon naught Q divided by R minus KA plus 1 upon 4 pi epsilon naught minus Q divided by R plus KA. We can calculate it. Q 1 upon 4 pi epsilon naught are the common. Q upon 4 pi epsilon naught is common. 1 upon r minus a, here is the minus sign, we can put it this. Q upon Q is the common. 1 upon r plus a. Q upon 4 pi epsilon naught, LCM is r square minus a square. Here r plus a minus r minus a. We can solve it. Q upon 4 pi epsilon naught, r plus a minus r plus a divided by r square minus a square. Q upon 4 pi epsilon naught, a plus a 2a divided by r square minus a square. We find out here v is equal to q upon 4 pi epsilon naught 2a divided by r square minus a square. We know that dipole moment, electric dipole moment P is equal to q into 2a. Here we put the value of q into 2a is equal to P. Therefore, we have V is equal to 1 upon 4 pi epsilon naught P divided by r square minus a square. This is the equation of dipole, electric dipole, the potential 8 point P. This is the equation for the electric potential 8 point P. Now, for an ideal dipole, A is less than to R. Therefore, we can neglect, or we can say here A is very small as compared to R. So, we can neglect the value of A square. So, our equation is made up, or we can write it. Then we can neglect a square as compared to r square. Then V is equal to 1 upon 4 pi epsilon naught P upon r square. Here we can write, this is the constant term, this is the also constant term, and we can write V is inversely proportional to r square. This is the potential which depend upon r. Now we can calculate the electric potential at a point on the equatorial line due to an electric dipole. Electric dipole, electric potential at a point on equatorial line due to an electric dipole. So we can draw a diagram for a point which is at a point of equatorial line. Therefore, let's consider AB. AB is a dipole where the point A represent minus Q charge and B point represent plus Q charge. O is the midpoint of dipole AB, and let's consider a point P is at equatorial point. Distance between O to P is R. Therefore, distance between point A to P and distance between point B to P is equal to, we can calculate this, we can write also this. Let's consider, let A be an electric dipole having charge minus q and plus q, separated by a distance 2a. O is the midpoint of dipole. We can also write O is the midpoint of dipole and P is the point where the electric potential is to be determined. Now let OP is equal to R and OA equal to OB is equal to A. The length of dipole is 2A, therefore OA is A and OB is also A. Now we can calculate the value of AP and BP. Here is the two triangle AOP and OBP. There are two triangles. Now we can find out the value of AP and BP. Here the base is A, the perpendicular is R. Both the triangle are same. Therefore we can calculate AP is equal to under the root R square plus A square. Both are equal, AP and BP are equal, therefore both the value are under the root R square plus A square. Now we can find out the electrical potential 8 point P due to plus Q charge is V1 is equal to 1 upon 4 pi epsilon naught Q upon R, means distance between B to P, or we can say plus Q to P, is under the root R square plus A square. First equation plus Q charge, and also electric potential point P due to minus Q charge is V2 is equal to 1 upon 4 pi epsilon naught minus Q divided by R square plus A square. Second equation. Now we can find out the total potential, and total potential is equal to V is equal to V1 plus V2. Now we can find out the total potential. Total potential 8 point P due to dipole AB is equal to V is equal to V1 plus V2. Now we put the value of V1 and V2 is equal 1 upon 4 pi epsilon naught is the common on the both the equations, so we can write q divided by r square plus a square under the root minus q divided by r square plus a square under the root. Both are the cancel out and the value of total potential is equal to 0. Therefore, we can write, we can say, thus the electric potential at a point on equatorial line due to electric dipole is 0. Now we can calculate the electric potential at any point due to electric dipole at any point, not an axial line, not an equatorial line. Electric potential at any point due to an electric dipole. Let's consider a dipole AB to A, midpoint is O, and a point P is considered is here anywhere. Distance between the point O to P is equal to R. Now we can calculate the value of electric potential at point P due to the dipole AB. Let the angle between BOP is theta. Let angle BOP is equal to theta. OP is equal to R. OA equal to OB is equal to A. Now draw a perpendicular. Draw BB dash perpendicular on OP. BB dash a perpendicular on OP. And AA dash perpendicular on, and AA dash is also a perpendicular on OP. We can say PO. We can also write BP, draw the line AP. Now in triangle OBB dash, in triangle OBB dash, OB dash बटे OB, OB dash divided by OB is equal to cos theta, and OB dash is equal to OB cos theta, and OB is equal to A, so we can write OB dash is equal to A cos theta. And also in triangle OAA dash, OA dash divided by OA is equal to cos theta and OA dash is equal to A cos theta. Now PB dash in the diagram, PB dash is nearby equal to PB. We can write PB dash is nearby equal to PB, or we can say PB is equal to PB dash. How we can write PB dash? PB dash means PO OP minus OB dash, OP minus OB dash, and OP is equal to R. OB dash here is A cos theta. So PB is equal to R minus A cos theta, and as at distance PA is nearby equal to PA dash, and PA is equal to PA means OP plus OA dash. OP is equal to R. OA dash we can find out A cos theta. PA is equal to R plus A cos theta. Now electric potential point P due to minus Q charge 8A is equal to V1 is equal to 1 upon 4 pi epsilon naught minus Q divided by PA, and we are also find out the value of PA. 1 upon 4 pi epsilon naught minus Q divided by PA is equal to R plus A cos theta. First equation, V1 is equal to. Now electric potential (8P) due to plus Q charge 8B, V2 is equal to 1 upon 4 pi epsilon naught Q plus Q charge है डिवाइड बाय PB, and PB is equal to R minus A cos theta. This is the value of electric potential at point P due to the charge positive Q at point B. Now total potential at point P due to dipole AB is equal to V is equal to V1 plus V2, and V1 is 1 upon 4 pi epsilon naught and V2 1 upon 4 pi epsilon naught, and Q in the both equation is common, and we can write 1 upon R minus A cos theta minus 1 upon R plus A cos theta. We can solve it. We find Q upon 4 pi epsilon naught, LCM is R square minus A square cos square theta, and we can calculate R plus A cos theta minus r minus a cos theta. Now we can solve it. Q upon 4 pi epsilon naught r plus a cos theta minus r plus a cos theta. R and R are cancel out, and we can write 2a cos theta divided by r square minus a square cos square theta. And we know dipole moment P is equal to Q into 2a. So Q into 2a can be equal to P cos theta divided by 4 pi epsilon naught r square minus a square cos square theta. This is the value of potential 8 point P due to the dipole AB. Now some special cases. First, when the value of theta, if theta is equal to 0, or we can say the value of electric potential 8 point P lies on axial line. Here angle theta is angle between BOP and A dash. So if theta is 0 degree, therefore the point P lies on axial line of AB, or axial line होगा तो we can put the value of theta is 0 degree, and when we put cos 0 we can calculate value of V, and V is equal to P cos 0 divided by 4 pi epsilon naught r square minus a square cos square 0. And after solving it, we can find out the value of V. The value of V cos 0 is equal to 1, and here the value of V is equal to P upon 4 pi epsilon naught r square, when we assume A is very less than as compared to R, and this is the value of the electric potential when we take the point P on the axial line. Now if the value of theta, second special case, when value of theta is 90 degree, therefore value of electric potential is V is equal to P cos 90 degree divided by 4 pi epsilon naught r square minus a square cos 90, and cos 90 is equal to 0. Therefore all the value of this term is equal to 0, and this is the value of electric potential when the point P is an equatorial point. Thus we can calculate the value of electric potential when the point P is on axial line, when the point is on equatorial line, and final when the point is anywhere on the near about the axial line. अगर आपको आज मेरे द्वारा करवाया गया लेक्चर सही समझ में आता है तो आप अपने कमेंट ज़रूर दें, और घर पर रहें, सेफ रहें। Thanks.